Hello smart people, Mr. H here. Welcome back for the second video. In this video I'm going to cover question 10, hopefully up to 20 in 20 minutes. Alright, we're going to go over problem number 10. Suppose we are given the following points. Line 1 passing through -3, -2, and 6, -5. Line 2 passes through -6, 3, and 3, 0. And line 3 passing through 3, 3, and -3, 5. Find the slope of each line. So find the slope of 2 points. You're going to use the slope formula. y2 minus y1 over x2 minus x1. So we're going to look at line 1. You have x1, y1, x2, y2. So that will give us y2 is -5. Minus y1 is -2. x2 is 6. Minus x1 is -3. 2 negative turn into a positive. Okay, so -5 plus 2 will give you -3. Opposite sign, you subtract, same sign, we add. So 6 plus 3 going to be 9. And we're going to reduce our fraction by 3. That will give you -1/3. So line 1 has the slope is -1/3. Line 2, so same concept, x1, y1, x2, y2. Same formula. y2 minus y1 over x2 minus x1. y2 is 0. Minus y1 is 3. x2 is 3 minus x1 is -6. 2 negatives turn into positive. That will give us 0 minus 3 is -3. And 3 plus 6 will be 9. Reduce it by 3, you will have -1/3 again. -1/3 is the slope of line 2. Line 3, same formula, y2 minus y1 over x2 minus x1. x1, y1, x2, y2. That will be 5 minus 3 and -3 minus 3. 5 minus 3 is 2, and -3 minus 3 is -6. Reduce it by 2, you will have -1/3. Interesting. So all 3 of them has the slope is -1/3. Now for each pair of lines, determine whether they are parallel, perpendicular, or neither. Parallel lines is line that goes side by side and never cross each other. That case only happen if you have the same slope. So in this case, line 1 and line 2, or also line 3, they are parallel to each other. Okay. So then we, unfortunately, in this problem, we don't see the case when they perpendicular. Perpendicular slope, I'm going to write down slope. Give me 1 second. M, perpendicular. Perpendicular. The slope is perpendicular to original slope when the slope is the reciprocal with opposite sign. So which means -1/3, we're going to flip them as 3 over 1, and opposite signs, since it's negative, is going to turn positive. The line is perpendicular to this 3 will have the slope is 3. Okay, one more example. If your slope was if the original slope was 2, then perpendicular slope gonna be, what do you think your perpendicular slope gonna be? It will be a reciprocal, which means 2 over 1. You're gonna flip it. That will be 1/2. And opposite signs, which means it was positive 2, it will turn -1/2. Alright, that will be the slope of the perpendicular line. Is neither when it's fallen into either case. Alright, number 11. Graph the inequality. You have x plus 3y less than or equal to -6. So there's multiple ways to graph this one. You can do plug in points, or you can get y by itself and use rise over run to graph the line. I will do rise over run. So first, we need to isolate the y by subtract x to both sides. That will give us 3y less than negative x minus 6. And then we divide 3 to both sides to get y alone by itself. So y less than negative x over 3 minus 6 divided by 3 is 2. Okay, I'm going to rewrite this as y less than negative 1/3 x minus 2. Then we will know our slope is negative 1/3. We know our b is negative 2. Then we can begin at negative 2. Negative 1/3, which means down 1 over 3. Down 1 over 3. Alright, but this is inequality. It's not like the regular line. You cannot just assume it's going to be a solid line. If it's greater than or less than without equal sign, it's going to be a dotted line. Greater than equal to or less than equal to, that will be a solid line. In this case, we have a dotted line. Okay, so we will connect 3 dots with a dotted line. Like this. Okay. Alright, beside that, you need to find the shading area. So you're going to do test point, which means you pick any point on the graph and plug it into the equation to see it true or false. The easy point to plug in is 0, 0. If 0, 0 is not on the line, then you can use it at any time. Our equation was x plus 3y less than negative 6. So we just choose point 0, 0, which means x is 0 and y is also 0. 0 plus 3 times 0 less than negative 6. 0 plus 0 less than negative 6. 0 less than negative 6. Is that true if we say 0 less than negative 6? 0 less than negative 6. Is this a false statement? Okay. Since it's false, you're going to shade the opposite sign with the area does not contain the 0, 0. So our shading area will be this side. Okay. 0, 0 give you false statement, so you shade the opposite direction. If it's give you true statement, then you shade the area contains 0, 0. Alright. Problem 12. Problem 12. For each order pair, determine whether it is a solution of the system of equation. So on the second page or in the back side of this page, you will see the set of solutions. In one of them, or maybe more than one, will be a solution. So there's 2 ways to do this. Either you solve the equation, or you can check the solution. I would prefer to solve the equation, because to me it's easier and it's less work compared to checking every single point, because you have to plug into both equations. Alright, so I will go ahead and solve for the equation. Y equal to 4x plus 7. So you're going to plug 4x plus 7 in place of y. We will have 2x plus 5 times 4x plus 7 equal to negative 9. Alright, then we're going to do is distribute 5 into parentheses. You will have 2x plus 20x plus 35 equal to negative 9. Then we combining like term, 2x plus 20x, that will give you 22x minus 35, plus 35 equal to negative 9. Continue solving for x. We're going to subtract 35 to both sides. Okay, that will give us, this cancel out, 22x equal to, same sign, add them up, that will be negative 44. To get x alone by itself, you're going to do is divide by 22 to both sides, x equal to negative 2. Alright, since x is negative 2, you can take this and plug it back into the original equation. Y equal to 4x plus 7. So x is negative 2. That means is 4 times negative 2 plus 7. That would be negative 8 plus 7. That will give you opposite sign, subtract them is negative 1. So our solution is negative 2, comma, negative 1. So in this case, you have one solution, meaning that two lines cross each other at one point. That point is negative 1, negative 2, negative 1. So yes on negative 2, negative 1. The rest will be no. Alright, we're heading to problem number 13. Graph the system below and write its solution. Okay, so we're going to look at the first equation. Y equal to negative 2x plus 2. Okay, and to graph this, we can use rise over run. So y equal to mx plus b, where is m is negative 2 and b is positive 2. Okay, so negative 2, to do rise over run, you need to write negative 2 in fraction, which is negative 2 over 1. Okay, begin at 2. Rise over run, but since it's negative 2, you go down 2 and run 1. So from the beginning, go down 2, run 1, down 2, run 1, down 2, run 1. Or you can also do the reverse, which is up 2 and to the left 1, up 2 to the left 1. Then we draw the line, go through them. Alright. Second equation, you have 4x plus 2y equals to 4. And we try to get y by itself to get in the form y equal to mx plus b. Minus 4x to both sides. 2y equal to negative 4x plus 4. Then continue isolate the y. You divide by 2 to both sides. Y equal to negative 2x plus 2. Okay. Interesting that the two equations look exactly the same. So which means that the slope is negative 2 over 1 and your beginning will be 2. So you will begin at 2, down 2 over 1. So this two lines is actually 1. They are on top of each other. Okay, so the solution for this case, see, they don't cross as one point. They are on top of each other, meaning that they touch everywhere. Okay, since they touch everywhere, that will be infinitely many solution. Many solution is our answer for number 13. Alright, we're heading down to number 14. Henry and Justin are driving separate cars to Chicago. They begin the trip with a full gas tanks. The amounts of gas in the gallons remain in the tank of each car depend on the number of miles driven, as shown below. So as you see that the graph has the x-axis is mile driven, and the y-axis is gas remaining. Okay, so we see one line is Justin's car, and the other line is Henry's car. After 150 miles driven, which car will have more gas remaining? Okay, so it's 150 miles. 150 miles, we see 60, 120, and 180. So it's increasing by what? By 30, right? It's increasing by 30. 30, 60, 90, 120. So the next 30 of 120 from 120 is 150. Okay, so 150, we going straight up. For Henry car, it was around 9 gallons in the tank. And for Justin car, it's about 16 gallons in the tank. Question is, which car has more gas remaining? So there's more gas remaining in Justin. He has 16 gallons in the tank. How much more gas will it have? Be careful on this one. They say how much more gas. So let's compare between two gas tank. So we have Justin is 16 and Henry is 9. So that will be 16 minus 9. That will be about 7. It is 7 gallons more. We are at part B. How many miles will the tanks contain the same amounts of gas? So, two line that intersects as 300 miles driven. So the gas in both cars are gonna be 6 gallons. in the tank. So how many miles will the tank contain the same amounts of gas? So the answer is 300 miles. If the number of miles driven less than this, which car will have less gas remaining? So less than 300, we can say 180. So who has less gas? That will be Henry car will be less gas compared to the other that you have to go higher up. Justin car will have more gas in the tank. Alright, so Henry. Alright, problem number 15. We're going to graph this two inequality. First equation, y greater than negative 2x minus 3. So m is negative 2, b is negative 3. Okay, you also need to know that if it's greater than or less than, you will use a dotted line. If it's greater than equal to or less than equal to, you will use a solid line. Okay, so in this case, this will be a dotted line. Okay, and you have to use test point to find out where to shape the line. So first, I'm going to graph this first. We're going to start at negative 3. Negative 2 over 1, so which means down 2 over 1. Down 2 over 1. Okay, then we draw the line, go through them. Oh, sorry, I just assumed that's going to be a solid line. My bad. Let's try it again. It's going to be a dotted line. Okay. Then we're going to do test point. Test point, I would like to choose 0, 0. As long as 0, 0 is not on the line, we're good to use it. So y greater than negative 2x minus 3, where is 0, 0 mean x and y is 0, greater than negative 2 times 0 minus 3. So 0 greater than 0 minus 3, 0 greater than negative 3. Is that true when you say 0 greater than negative 3? The answer is yes, it's true. If it's true, you're going to shape the area that contains the point. So 0, 0 is above the line, so we shape everything above the line. Okay. Alright. Now, second equation. Y greater than equal to 5x minus 2. M is 5 over 1. B is negative 2. And since there's an equal sign there, that means this is a solid line. Start at negative 2. My bad, negative 2 right here. And up 5 over 1. 1, 2, 3, 4, 5 over 1. 1, 2, 3, 4, 5 over 1. Then we connect them with a solid line. Test point. Test point, we're going to use the point 0, 0. Okay. Because it's not on the line. It does look like it's on the line, but it's not on the line. Because you're beginning at negative 2 instead of 0, 0. Okay. So y greater than equal to 5x minus 2. Y is 0. Greater than equal to 5 times 0 minus 2. So 0 greater than equal to 0 minus 2. 0 greater than negative 2. Which is true. So we're going to shape the area that contains the point 0, 0. So you're going to shape this area. Okay. Now, as you see that there's a changing in my blue line right here. So the intersection which create the changing in color, that is our solution. Okay. Solution is right where they intersect. Okay. Solution here. So on Alex, you don't have to, or you do not shape the two sides, shape the part that is the final solution. You can shape them and then erase the extra part after. Okay. Alright, we on problem number 16. Number 16, solve the following system of the equation. we have 2x plus y equal to 12 and 5x plus y equal to negative 16. Seeing the equation is already in standard form with it x and y on the same side, we can solve the problem by elimination. Okay, as you see that the y look the same. So to eliminate y, you need the opposite signs. So what we're going to do is multiply one of the equation by negative 1. Or basically change the sign of the equation. So negative 2x times negative 1 is 2x. Y times negative 1 is negative y. And 12 times negative 1 is negative 12. Then we bring over the second equation. 5x plus y equal to negative 16. Okay. Alright. So now when we add two equations, negative y and positive y cancel each other out. 2x plus 5x is 7x equal to negative 28. Then we divide by 7 to both sides. X equal to negative 4. Right? 4 times 7 is 28. Then we take this answer, we're going to plug it back into one of the original. It doesn't matter which one. I like to use the second one because it'll look easier to me. 5x plus y equal to negative 16. We know x is negative 4, so 5 times negative 4 plus y equal to negative 16. 5 times negative 4 is negative 20 plus y equal to negative 16. So we're going to add 20 to both sides. Y equal to positive 4 as the final answer. So the point is negative 4, comma 4. Alright, the video is quite long now, so I'm going to pause right here. So we go from problem 10 to 16 in this video. Alright, see you all on the next video.